All right, today's lesson, we're going to learn about the age of the Megalodon, when it lived. We're going to talk about paleontology, we're going to talk about paleontologists, we're going to talk about fossils, and we're going to end it with a discussion on the geological timescale. And then you guys are going to have a simple little exercise that you can do to help you understand the length and the time involved in the geological timescale, which is actually the age of the Earth. All right, so up to this point, you guys have been doing some lessons and you've learned already that the Megalodon is extinct. And extinct means that it's no longer here. And so if there's a creature as big as the Megalodon that hasn't been here for 2 million years, how in the world do we even know it was here? Well, there's scientists that can answer those questions for us, and they're called paleontologists. Paleontologists study paleontology, which means ancient life. I'll put this around my neck, put my hat on. I'm going to pretend like I'm a paleontologist today, going out in the field and looking for fossils. So a paleontologist would have items like a rock hammer, be chipping on the rocks. They would also maybe have a chisel. So they're out there in the rocks, chiseling away and looking for fossils. Now fossils, most of you probably know what a fossil is, but just in case, a fossil is an old plant or animal that has died and it gets buried, and if nothing disturbs it, then over hundreds of thousands of years, it turns into stone. And so a paleontologist would be a person who would go out in the field, take all these tools with them, have this little magnifying lens to take a close look at fossils. Here's a great example of a fossil that I brought from home. They would take really good looks, close looks at the grains and so on and so forth. And with some other laboratory type of tools, they would actually be able to date this. In other words, they would be able to tell how old this fossil is and be able to tell when this particular critter lived on our planet. And so with the Megalodon, that's what they did. They looked for teeth. If you look right over here, there's a really great example of a shark jaw and a tooth that's in the middle there. This particular little shark's tooth is a different type of shark. They would date these particular fossils, and that's how they know that the Megalodon was around some 2 million years ago. Where do the paleontologists find these fossils of the Megalodon? Well, the Megalodon was actually a pretty successful shark, and the fossils that can be found on many of our continents around the planet. The Megalodon flourished. They had much bigger oceans at that particular time, and so the Megalodon was really flourishing. And remember, these sharks were huge. The Megalodon is like the size of your school bus. Can you imagine a shark as big, long as your school bus, and a big around as your school bus? Really big fish, had to have a lot of ocean to swim in, just the right temperatures, and it was happy. But something happened right about the time, they call it in the geological timescale, they call it between the Pleistocene and the Pliocene. And we'll talk about that a little bit later. But something happened with our continents at that point. At the time that the Megalodon lived, our continents were not in the same place as they are now. If you take a look at this bottom map right here, you can see that North America and South America are separated. And so that allowed for a much bigger ocean. So the Megalodon was super happy because it had a large ocean area to swim in. But over time, during the Pleistocene and the Pliocene, those are eras in the geologic timescale, things changed. The climate started to change, the continents were moving, and so North America and South America came together. If you take a look at the second map, it should look familiar to you because that's how it looks right now. And so North America, South America came together, and well, it cut off the ocean. And when it cut off the ocean, the Megalodon had less space to move around. And also, climate was changing then. Right now, it seems that our continent is getting warmer. But back then, it was getting colder. So the waters got colder. There was less ocean for the Megalodon to swim in. And so over time, the Megalodon couldn't survive that. And it eventually died out. We're going to talk about the geological timescale. The geological timescale is a lot like our calendar. The biggest unit is the year, and then we have months, We have weeks, we have days, and I guess you could say we even have hours and minutes. The geological time scale is a representation of the age of the Earth. And so in geological time scale, you have units like that, like your calendar. We have big ones, and then they get smaller as they go down. The biggest unit in the geological time scale is called eons. And then the next is eras. After that is periods. And then we have the smallest one are called epochs. Does anybody know how old the Earth is? Well, the Earth is actually 4.6 billion years old. That's a really, really, really large number. Kind of hard to wrap your head around. For a long time, there weren't any plants and animals. The Earth was this toxic, gaseous, molten material that had some hard, solid chunks in it. And it was spinning, but supposedly the Earth was formed by a big bang. And particles had spinned off of that particular explosion. Our planet was one of them. And so it was not a good environment when the Earth was starting to form. There weren't any life forms at that time. It took about 1 billion years before there was any life. And that would be the tiniest microscopic little particles, plants, animals like algae and bacteria. That's how life started. And then over millions and billions of years, it turned into all the animals and plants that we know of today, including all the ones that have gone extinct, like the dinosaur, like the Megalodon, all the way up to us. We're like the last animal to form. And so the geological time scale is kind of hard to wrap your head around. I'm going to give you an example. You guys have had a root beer, right? I wish I had one right here. I'd probably drink it down because it's kind of warm in here. So your mom or you get a nice big frosty glass. You open up a bottle of root beer and you pour it into the glass. What happens? You get this good stuff, this brown, amber looking stuff at the bottom, and then you get a layer of foam at the top. Well, the reason I'm bringing up a root beer is because the geological time scale is kind of similar. If you think about all the time that went by before life really started happening, before plants and animals started happening, it would be like that whole amber part of the root beer, the good stuff. And then the little layer of foam on the top would be like the time period in geologic time that all the animals and plants evolved. And some of them went extinct, some of them stayed, and then people, us, we're the last ones that come on the scene. We're right up there at the top where the little bubbles, like when you put it up to your mouth and little bubbles kind of tickle your nose, that's when we evolved. So when you think about the geological time scale, remember the little analogy about the root beer. The Megalodon was in the foamy part, if you will. So the Megalodon is pretty young in geological terms, although it's been extinct for about 2 million years. So that's all I wanted to share with you today about the geological time scale. Now you guys have an exercise. I'm sure your teachers will hand this out to you, or you can have printed at home if you're a homeschool student. That you have an exercise that you can actually download. Has some terminology, some of the terms I talked about today and some I didn't cover, but you have the definitions there that will help you with this exercise. And then you have 2 pages like this. So you have a representation of a football field. Well, it's kind of like that root beer. It's going to be a representation of geological time. And so what you're going to do is take your printed football field page here. I'm going to call it cheat sheet because this is one that's kind of already done. You can take a look at this one and just transfer these numbers, these years right here, transfer them over to your football field. Okay, you want to do this first. And then you're going to take this sheet and cut out all of these little pictures of plants and animals. Then you'll have a little legend right here that tells you, for example, the first fish lived 510 million years ago. And I believe when they say the first fish, they're talking about this one right here. Again, if you need to, you can use your cheat sheet. So you would take your football field that you've already marked the geologic time on and take your cutout fish and put it on the football field where it belongs. That way you're going to be able to see, if you do this correctly, the page is going to look something like this, and you'll be able to see that the first fishes, when they came about, and then all the other organisms, the plants and animals, there's a dinosaur, all the way up to, there's another type of dinosaur, and then the Megalodon. Geologically, it's kind of a young critter. Humans are up here at the top. We were the last ones to evolve. So I hope that you enjoyed this lesson today, and I hope you enjoy the little exercise. And I really hope that when the museum opens that you'll come out and see the exhibit on the Megalodon. If you have any questions about today's lesson, or you have any questions about the museum or the exhibit, you can go to the Western Heritage Museum Facebook page or the website. Have a great day.